Hello and welcome back. And I've decided to put a short segment in here specifically for the logical operators. The logical operators in Java are and, or, and not. And these are used in English, but they're used poorly in English. But let's see if we can look at the logical behavior. So I will eat lunch if it's noon and I'm hungry. So this English phrase, it's noon and I'm hungry. So there's a left-hand side and a right-hand side. And the and is saying that both of those have to be true. It's noon and I'm hungry. That's when I would get to eat lunch. The logical or, if it's noon or I'm hungry, that means that if either of those are true, then I could get to eat lunch. So that's the correct interpretation of and or in English. And a lot of times people will use these incorrectly, but everyone knows what they mean. So suppose I said, everyone stand up if you were born before 1960 and after 1990. Well, there is no one who was born before 1960 and after 1990. So you couldn't possibly have this expression evaluate to true in the Java sense. So let's look at the and, or, and not, the logical operators that we have in Java. So these are the and operators, and there are two of them, and I'll tell you why there are two later on. This is the or. This two keystroke and one keystroke operator, those on your keyboard are just below the backspace, so it's shift backslash to get the or character. And the not operator is the exclamation point. All of the logical operators use Boolean operands and evaluate to a Boolean. So they only work on true-false values, and that's why they're called logical operators. So here's how they work. If A is greater than B and C is equal to 25, so both of those would have to be true in order for this expression to evaluate to true. So this is a relational logical expression with relational operators and a logical operator connecting them. So here's an or. If A is greater than B or C is equal to 25, if either of those are true, then we'll go in and execute the body of this if. And here's not. If not A is greater than B. This is a little bit silly because we could have written if A is less than or equal to B and had the same thing. But sometimes it makes sense to express the condition in the way that you want it to be thought of in the application. So sometimes if we're checking for A is greater than B, and we want to do something if that's not true. So not inverts the logic. Not true is false, not false is true. Let's look at all of the possible combinations for using these operators. So Booleans are the operands all the time. True and true are the only time that the and operator will yield true. So both of them have to be true. All of these other combinations will yield false. For the or, false is the only time that the or operator would yield false. All of the other combinations of or are true, including true or true. So if both of them are true, still you have at least one of the other. So it evaluates to true. These are called the truth tables. The simplest truth table for the not operator is the simplest truth table is for the not operator. Not true is false and not false is true. Well, that's what there is. These are all of the combinations of true and false for the and, or, and not. Not is the only of the logical operators that has only one operand, so it grabs onto something on its right, and or have a left and a right operand. Okay, when I first started this, I showed you that there are two AND operators and two OR operators. So here are the two logical AND here are the two logical OR operators. And the difference between them is a short circuit behavior. So these operators, the two keystroke operators, are the ones that you would use most of the time, and unless you have a good reason not to. Now let's look at what the short circuit behavior is. If you're using the AND operator and you have false on the left, you know the answer. Without looking at what's on the right, you know that the answer is going to be false, because false and anything is false. So for efficiency, you don't need to evaluate whatever's over here if you have false on the left. The same thing happens for OR. If you have true on the left, then you don't need to evaluate what's on the right. Because true or anything, it doesn't matter what comes over here. If you have true on the left, you know the answer. So the only time you would really need to use the no short circuit operators is if there's something going on the right and you need it to happen. And this is called a side effect. It has nothing to do with evaluating the veracity or the truthness of the expression. We already know that the truthness is determined in these cases just by looking at the left-hand operand. But let's look at this one. If A is greater than B, so we have 10 is greater than 6, that's true. And now we have true on the left of an OR. So if it's a short circuit OR, we will not go over to the right-hand side and evaluate it. And here's the side effect. There are lots of possible side effects, but the one that we know about right now is we could increment a variable on the right-hand side. So in this case, B would not get incremented because the left-hand side evaluated to true and the operator short-circuited and did not go and increment the B as part of evaluating the right-hand side. If you use this operator, then it will not short-circuit. So A is greater than B, that's true, but then we're going to go and increment B and test to see if it's greater than 6. The test won't make any difference because we already know that this whole thing is going to evaluate to true. But the incrementing of B will make a difference. So let's be sure that you understand there is no difference in the logical determination of the expression's veracity or true and falseness. It's a question of whether to evaluate the right-hand side. A few precedence issues that I want to bring to your attention. A lot of people think that and or get evaluated from left to right. But if these expressions get complicated and you are combining lots of things with ands and ors, and they can be as complicated as you need them to be, how would we evaluate this one? We have true or false and false. If you evaluate this from left to right, you'll get the wrong answer. The and, the logical and, has a higher precedence than the logical or. So false and false is false. True or false is true. If you do it from left to right, you'll get the wrong answer. The reason that people find this hard, I think, is that a lot of combinations of true and false wouldn't make any difference. This one combination of true and false can cause you a pretty serious bug if you don't know that the and is happening first. Okay, let's look at the precedence issues with the not operator. Not is a unary operator. That means it has only one operand. It grabs onto what's on its right. And it has a higher precedence than the binary operators. That means operands with two operators with two operands. So look at this one. It looks pretty simple. If not, A is greater than B. And this will not compile. It would try to do not A first. But A is not a Boolean. And not will only work on a Boolean. So the error message here would be, I can't evaluate not A. It's not exactly what the error message will be. So most of the time when you see the not operator used with relationals, you will see the relational operator being forced to happen first using the parentheses. So if we're looking for not A is greater than B, then you have to force the relational to happen first. And that can be a sticking point. Unary operators have a very high precedence in general, in all languages. So if you're having trouble getting something to compile, make sure that you check out whether you're applying a unary operator to something that you don't intend to, like this one. Here are some practice ones. Evaluate the relationals first, then evaluate the logicals, and these will all evaluate to true or false. I would encourage you to do these with a pencil and then go and type them in a little program in Eclipse. You could just do a system out print line and put this in it and see if it prints out true or false. It's really simple to ask the machine what the answer is to confirm that you're doing the logical operators correctly. Okay, I told you this would be short. Logical operators have Boolean operands and they evaluate to a Boolean all the time. There are 3 of them, and, or, and not. And I put a note in here. In Java there is actually a very obscure logical operator. It's the hat operator. And it's exclusive OR, where one side must be true and one side must be false to evaluate to true. And it's almost never used, and most textbooks in Java don't even mention that it exists. But I like to say there aren't any more, there never will be any more, and it gives you confidence that we've covered everything we need to. And I couldn't do that here by talking about these 3 unless I said, oh, by the way, there is this one that no one ever uses, exclusive OR. You might find some place where you could use that. I don't think in all of these years I've ever used it. Okay, short-circuiting. We looked at the short-circuit behavior with and OR, and those operators are a little bit more efficient. Well, sometimes they're a lot more efficient depending on what's on the right-hand side. And those are the ones that you should be using unless you have a very specific need to force the evaluation of the right-hand side. I got tired and didn't type that apparently. And the precedence issues. Not happens first. It's a unary operator, high precedence. Relational operators, then and then or. So and has precedence over or, and that's the one that people mostly don't do correctly. Okay, well, we'll move quickly to doing stuff that will give you some tools for solving some more interesting problems.